So chat, I am going to give you a breakdown into how I manage Kubernetes clusters. When I say how I manage Kubernetes clusters, what I really mean is how I manage Kubernetes clusters at companies. Do you need to do this to manage a Kubernetes cluster by yourself? No, as a matter of fact, you probably shouldn't. You should probably figure out a much simpler and easier approach. What I'm going to show you is how you can make a self-serve Kubernetes cluster. How can we craft the best developer experience? What are our key indicators, the things that we care about the most? The biggest thing is like configuration. So I really want to be able to do configuration, deployments. Like that's all I really care about. As a developer, I want to be able to change my service. I want to be able to update it, deploy it, create new ones, add, delete old ones. We want to have a way of like doing service management. And when we have service management, we really want to be able to not have that definition linked to a specific technology. And so what I mean by that is I want to be able to say, I just want 2 cores and 4 gigs of RAM, or I just want to run this image with this much disk space, or blah, 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 or whatever. It shouldn't say, I want to use this S3 bucket or this Docker technique or blah, blah, blah. Sort of like an IDP, integrated developer platform, which is the idea that as a developer, you really only care about this. In the operation of concerns, this is all you really care about. How do I configure my services? How do I deploy them? And really just how do I manage them in general? So this is like our first abstraction. And so we create something called platform directory in order to do that. It's managed completely by GitOps, which means that as a developer, my configuration interface is GitOps. I go into source code and I make some changes. And the idea here is a configuration language that is approachable as a developer. So if we go into this repo, the only directory you need to worry about is the config directory. If we go into config, you'll then see that we have effectively what are called queue files. And so we want a way of managing this data in a way that's also very expressive. If you want to like reuse variables or other things like that, you want to be able to do that. What we did is we chose Q as a configuration language that the developers use. So technically, the developers use Q as the configuration interface. So for example, I want to create a service. I could go to the service.q and then you'll see all of our services in here. And so this actually has a service for Quirk. The service is called Discord bot. And then you can even see like which versions are in the environment. So we deploy by SHA, meaning that this gets updated whenever we want to deploy like a new version of that specific service. So you can see that right now, dev and prod are both running off of the same version. You can see our configuration is plain text, so we don't have to worry about storing these values in the repo, but we can also use like really nice language benefits like Q being able to target things in maps or reuse variables and things like that. We also have secrets, so I have the ability to define secrets and then go and manage those manually. This is the interface. This is that first layer, which is just like configuration, deployments. That's all it does. Queues for configuration and code generation. That's pretty much all we use it for. So as a developer, I can come in here and I can just say, I copy and paste this, add my service, and then I should expect that when I commit this and merge it, within a certain amount of time, my service just appears. Now, the reason why we call it platform directory is because you can take that same concept and you can actually use it for defining resources in your infrastructure as well. So for example, if I wanted a Kubernetes cluster, then I could do the same thing, right? It's all just configuration and parameters and stuff like that. So just like I have like an environment and services and stuff like that, I can also define resources. For example, if I wanted to, I could go into infra. I could go to Alt F4 LLC, and then you'll see here that I actually have a set of files that already exist, like an AWS CDN, an AWS network, Proxmox Kubernetes, like all this stuff. This also enables me to create a configuration that I can define my own configuration around resources, and then in other like Terraform repos and stuff like that, provision those resources automatically. And so for example, if you look at like AWS CDN, you can see I have a config called AWS CDN blog, static website hosting true. So what this means is this is going to create me a CDN with the name blog on Amazon, and then it'll enable static web hosting for it. But what if I'm not just on Amazon? For example, what if I want to like manage a Kubernetes cluster on Proxmox in my home lab? Well, that's where the Proxmox Kubernetes comes in place, where I can say, I want you to create that cluster for me and then do whatever. So what happens is when that gets committed and merged, any downstream repositories simply just need to go out and fetch that configuration, look for changes, and then run their own applies. So this is the second part in the component. This also makes it so that other systems can read that configuration. So I've defined how I can do configurations, infra, and services. So this is really about configuring your infrastructure and your services. That's it, just configuring. If they exist in platform directory, then that means that whatever actually is in charge of provisioning those resources downstream should then do so. So for example, when I go in here and I add the Kubernetes cluster, me adding this does nothing. The only thing this does is just adds it as a configuration value in a data source that other things can then look up and ask, is there anything in the Proxmox definition that I need to provision? What happens is those other repos then go out to platform directory and get their specific configurations that they need for their relevant resources. And in this case, in this specific case, this is manifest flux. So what we want to be able to do is configure infrastructure and configure services here. And then once I merge this, I want anything that then reads from platform directory in the future to get those changes. If I'm configuring everything here and I'm working with Kubernetes, the next problem I really need to solve is provisioning. That's really what we need to do. And so that's what we're using manifest flux for. That's the second component in this stack. So manifests and Terraform. And then you can have all of these repos just like run on a cron, and then they will just check platform directory for all of their configurations. Now your deployment is much different. Instead of having to like go to this repo, make changes, merge, and da-da-da and all of that, we just tell the manifests in Terraform to make an HTTP call. We do like a data lookup in Terraform into platform directory. We get all of the relevant Terraform configurations that we want. So if it's like a repo that provisions Proxmox resources, then we just look in the Proxmox stuff. Now at this point, we would have Terraform create us a Kubernetes cluster. But the next thing we need to do is we need to handle our deployments. And this is all services. That's that third part of the stack that we need to maintain. And so the way that we do this is we then tell Kubernetes to read from the manifest repositories. And this is where like FluxCD comes into play. So then what happens is Kubernetes looks at my manifest repo, which is then reconciling from my platform directory repo. I just added a service here. My manifests get regenerated here. And then Kubernetes sees those regenerations and goes, let me go ahead and pull them in and deploy them. Which teams can directly push and touch to the manifest? That's a great question. Like, who can manage what? The separation of concerns here would be that DevOps and platform manages all of this. And then this is your developers. So basically, everything in the purple is what the developers are concerned with, and everything in the pink is what DevOps and platform teams would manage and maintain. I've already shown you platform directory and kind of like how it works in a very, very simple overview. The next repository that's important is manifest flux. At some point, you'll have so many services with so many manifests, and then you'll have clusters that need each one of those manifests that you get to a point where you're like, okay, I need to code generate these things. So I basically have repos that manage manifests and repos that manage Terraform. So what happens is when these run, whether it be manually, whether it be on cron jobs, when you run these generations, they go out and they communicate to the platform directory first before they run any generation. And then once they run that generation, they run it off of the data that they got from platform directory. The manifest flux repo is actually a CLI tool built in Go. It's a custom built CLI tool that's entire focus is to take manifest templates and then combine them with the platform directory configuration to then generate our manifests that eventually get provisioned into Kubernetes. So you can kind of think of how I'm using Terraform and how I'm using the manifest generation as like a middleware, where basically we only really generate manifests and Terraform based off of what's in platform directory. But we have Terraform resources and manifests that coincide with configurations. That's basically how that works. And so manifest flux is actually a repo we need to like revive. If you notice, This is manual. This is the part where you touch and change things. But then everything else underneath it is automated. If I go into configurations and infra and I add a Kubernetes cluster, that will be managed by the Terraform repositories. If I go in and I add a service, then that will be managed by the manifest repositories. And then what happens is once all of these are taken care of and updated, Kubernetes goes out to the manifest repositories, which was created by Terraform, to then deploy its secrets. Just to be clear, let's go back to platform directory. You'll see here that I have like a Q export. So what I can do is I can run Q export on like a specific directory of Q files, and then it will combine them and render me JSON. You'll see I can actually pipe it into JQ, and then I could like start parsing it. And that's the point as well. Like Terraform will go out and look at the data, and if it's gone, Terraform knows to delete it. So you can delete and create resources by just making a call and seeing if it's there or not. But we also use Q to generate schemas. So it makes it really easy. We don't have to worry about all those changes. Everything else updates downstream. So Q does allow you to go from Q to OpenAPI specs. If you don't know what OpenAPI is basically a way that you can define a schema in one language and then generate that for tons of different languages. There is another part to this, and this is why I said manifest and not manifest flux, which is there's actually two different repositories that manage manifest for Kubernetes. But basically, we have a manifest flux, but we also have a manifest ArgoCD. And manifest ArgoCD is literally meant to solve the exact same problem as manifest flux. It just manages service level stuff. So basically, the manifest flux repo is for managing all infrastructural services of the cluster. If I wanted to make it so that ArgoCD that's not currently on a cluster gets added to it, I can just add it in my configuration, enable it. The manifest flux generates it, reconciles the Kubernetes cluster, and now I have ArgoCD. And then if I say, okay, now I want to deploy a service, then I add my service here. The manifest ArgoCD repo runs, not manifest flux, which means no deployments to infrastructure will change or affect service deployments, which is why they're separated. We do have two different repos, manifest flux and manifest ArgoCD. We do use both, but we actually use manifest flux to deploy ArgoCD. So that's kind of the difference there. Something needs to also deploy ArgoCD, so we use manifest flux to do that, as well as like basically set up the infrastructure of the cluster. And then ArgoCD is only worried about services. To kind of like do a quick recap here, I explained to you how we manage Kubernetes, or at least how I manage Kubernetes. The concept of platform directory, the concept of configurations and all of that existing in one area on its own. The goal here is that everything gets configured here. You want a new Kubernetes cluster, you add it to platform directory. You want a new service deployed to that Kubernetes cluster, you add it to platform directory. But the goal here is that you take that configuration and then you change it into some kind of way so that other repos can like pull and or request that data. So in our case, we create an API gateway, which you're actually looking at right now. And what happens is these repos here in the second layer make requests to this. You make a change, these reconcile from those change, and they have specific tasks that they have to do. We have our manifest and our Terraform repositories. That's the next layer. This layer is all about taking the data from platform directory and doing something with it. And then what happens is the Terraform runs, creates our Kubernetes cluster for us out of the box. And that's that third layer, the third tier here, the deployment part. So again, configuring, provisioning, and deploying. And there is a difference between provision and deploy. The easiest way to put it is deployments are really service focused, whereas provisioning is all about like manifest and Terraform and stuff like that. So yeah, what's the main takeaway here? It's a bit of a custom solution, but it really does kind of solve all of the problems that we want it to. So thank you guys so much for hanging out with me today. I don't know if you're in the Discord, but if you want, be sure to join the Discord. Also, please be sure to subscribe to the YouTubes. We also have the blog. Be sure to check that out. I hope, if anything, this helped everyone who's watched this maybe feel a little bit more confident about Kubernetes and managing it. Thank you so much again. Have a great rest of your day. Peace out.